So question 3 asks us to write an expression in the form P, meaning the probability of a certain inequality. So the probability that a woman would be between 5 foot 1.5 inches and 5 foot 8.5 inches is 68%. So the probability that the height would be between 5 foot 1.5 inches and 5 foot 8.5 inches is 0.68. Now the one thing here is we wanted height in inches, and here we have feet and inches. So 5 feet, we want to change that to inches, so we want to multiply by a fraction that has feet in the denominator, so we can remove the feet, and inches in the numerator. So we're going to multiply by 12 inches over 1 foot. The feet cancel, and when you multiply across 5 times 12 is 60 inches. So let's write this in our better format, our final format. 60 inches plus 1.5 inches, that would be 61.5 inches. And 60 plus 8.5 inches would be 68.5 is 0.68. So that's your answer. The probability that height is greater than 61.5 and less than 68.5 is 68%. Okay, so in a group of 500 women, how many would you expect to be taller than 6 feet? All right, so let's go up here. 1 standard deviation, 5 foot 5 inch was your mean. Add 3.5 inches. So add 3.5 inches to 8.5 inches. 8.5 plus 3.5 is 12 inches. That's 5 foot 12 inches. That's 6 feet. So that's 2 standard deviations from the mean. And this is 13.5%. So the question here is, in this group of 500 women, how many would you expect to be taller than 6 feet? That would be over here. The only thing left out here is 2.5% greater than 6 feet. So 2.5% of 500. Change the percent to a decimal. So we want to move our decimal point over 2. 0.025, the word of means multiply. 500, we're going to get 12.5 women. Pardon me, and you don't want to leave your answer like that. So you can either put it down to 12. We would expect 12 out of the 500 if you want to round down. Or really what would be better would be to say 13. Probably 13. That 0.5, we want to put that up. We would expect 13 women of the 500 to be taller than 6 feet tall. Now here we have on a campus, 95% of the students work between 6 and 12 hours per week. And the number of hours worked is normally distributed. Okay, so it would fall on that curve. What is the mean number of hours likely to be? And what is the standard deviation?